ಓಕೆ, ಇನ್ನೇನು ಮಾಡಬೇಡಿ, ಅದಕ್ಕೆ ಇರಲಿ, ಮ್ಯೂಟ್ ಮಾಡಿದ್ದು ಅದು.
हाँ मैडम, आप पहुंच गए ना? ओ, 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 ओके 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 ओके, ट्रैक 1 ज्वाइन करना। ओके। हाँ प्रणव सर, हाँ कर दो कर दो, बीजा जे भी आया हुआ है तो चालू कर दो।
મારો કેમેરો ઓફ લઈ
Good morning, Dr. Dubey. Shall we start?
Good morning, sir.
Good
We
morning.
can start, sir.
Okay, we were waiting for you.
Okay, sorry, because there was some internet problem. I log in using some other networks.
Okay, no problem. It's okay. We are just 4 minutes behind the schedule. No problem. It's
Okay,
fine.
sorry for that.
Okay, good morning, everyone. Uh, on the behalf of the Technical Program Committee, uh, as a Technical Program Committee Chair, I would like to welcome you all to this third International Conference on Soft Computing and its Engineering Applications. The theme of this conference is soft computing for smart nations, and this conference is technically sponsored by Springer USA and financially co-sponsored by Charotar University of Science and Technology and Department of Science and Technology, Government of India, and GUJCOS. Uh, we have total around 17 technical sessions in two tracks. In a track one, that is mainly for this Springer paper, and track two is for non-Springer paper presentation. So that is only for oral presentation, track two. In this track one, we have total 10 technical sessions, and we have 5 invited talks and one keynote speech. So we'll start this first technical session, and today's we have Dr. Tanuja Dope as a session chair for this technical session. I welcome you, madam, to this technical session officially now again.
Thanks.
Okay. So we'll start the session. I will make you the presenter, Dr. Dope, and I will
Okay.
forward this control to you. You can ask to join the author or presenter to give his presentation. Just give me
Okay,
one
sir.
minute.
Okay.
Dr. Dope, now you are the presenter. You can ask the author of the first paper to present their paper.
Okay, sir. Thanks a lot. Uh,
Welcome, madam. So the author of the first paper, that is Dr. D. Narasimha, and the title of his paper is Segregation of Arachnoids using 3-band photometry and deep neural network. Paper ID is icSoftComp2021. Dr. Narsiva is present over here. So I will make Dr. Narsiva as a presenter. Dr. Narsiva, are you ready?
I am ready, but you have to allow me for screen share mode, Professor Patel.
Yes, I am making you the presenter. Then you can share your PPT.
Okay. Rather PDF file. Okay.
Yes, it's okay. Dr. Narsiva, are you right now the presenter?
Yes,
So
I will try. Please try. Presentation. Which one? No, that I have pressed. Browse. Browse. Load from my computer.
besides the leave button, there is a up arrow button with up arrow.
icSoft. Can you see it? Yes, icSoft. What can be done? Press it here. No. Press it here. Oh, press it and then
Dr. Mersiva?
Are you? No one later. Professor Patel, are you able to see the file?
Yes, we can see your
Okay.
PDF file.
Please go back. Okay, if you can see the file, I will start.
Yes, we can see. You can maximize.
I think I will keep it.
It's okay, no problem, sir.
Okay, if I make, okay, I will start.
Okay, sir. Dr. Dope, are you there?
No.
Yes, sir, I'm here.
Okay.
Okay, I will start. First part.
Yes, sir. You
This
please proceed,
is
sir.
a work with astrophysics, agriculture, and technology. I am very grateful to the organizers, Charter University, for giving an opportunity to present it, because if you look at myself from astrophysics, Professor Samarth Raut and the two students from mechanical engineering all had small contributions but to be put together. Professor Rajshekhar Bhatt from electrical engineering, Professor Prabhuchandran from computer engineering, then our experts from the workshop. All these people putting together needed a little bit effort, and even our writing, we found that the computer people will have difficulty following. So in that sense, any input from you, not only about the presentation, even about the work-wise, it will be very helpful. So I will be grateful. Again, I am grateful to Charter University and input from any of you. Now about the statement of the problem, I think this will tell. You have a typical farmer, whether in the Malenadu of Karnataka or very many places in India. Let us say he has 1,500 such palm trees. Here is one such palm tree. The skilled labor has to go up maybe 5 meters, maybe 30 meters, and out of this carefully bring down. Let us say in this case, in this particular palm, some 3 such bunches with these colors without affecting this one, and in the neighboring, this still flowering, etc. Once they are brought down, you separate the individual areca nuts. Here remember, this green one may be just 4.5 months since flowering, whereas this could be 9 months or so. So in the interior, this green one will be very tender, and the processing should be different. These reddish ones and orange colored, they have to be dried and processed completely separately. Now, if the farmer, he has, once it is brought from the farm, less than 1 week to do the processing. If he waits more, the shell and the inner kernel, they will stick to each other and the quality will go down heavily. So, if he does not separate and do properly, this left side is what he will get. If he separates properly and processes on time, this red supari is what he will get. So this is the task. And what is the other problem apart from this 1 week or less? It is a skilled work. You do not get very many people. And these areca nuts, in the rainy season, they are sprayed what they call burdu mixture to prevent pesticide. And for that has copper ion, and if you are continuously exposed to it, it is not going to be good for health. So because of these two reasons, you want automation. So the thing is, myself and another some team members, we were invited by the so-called Totagara Farmers Association in Sirsi, some 120 kilometers from here. We had a day-long direct chat with the farmers on the problems, what can be done. So that is why this project came. We are still not even halfway through the project because there are very many things. Yes, by now it is clear to you. So the aim is to segregate what I showed from that palm, what you get, into 5 types. Very tender, 2 ripe orange red, and some broken thing. The second part is the green ones, what you showed, it is more like peeling is proper. Whereas the deep red, of course, you have to dry separately. The yellow is more of dehusking. So in that sense, a machine should do. We took this second part, the machine part, dehusking, as a secondary because there are already machines. However, the farmers say because they do a single kind of process to all of the arecanuts, it may be some 20% damage. 20% is a lot. So not many people want to use them. So this is the thing. Now, the basic principle of separation. I will go to astrophysics without explaining too much. Just this is the thing. Suppose you take a star, do your normal RGB in web camera type of thing. This has been well established during the last 80 or 90 years. So what they say in the old photographic plate, UBV diagram. You have photographic plate, nice filters, and take the image in ultraviolet, near, blue, and V. And you plot a diagram. This is a logarithm, so U minus B independent of distance, flux ratios. So the essential idea is that if the stars like the sun or Agastya, any of them, or Abhijit, if they were a perfect black body, this black line, that is the main thing, somewhere there the star would have been there, and if the sun were here, you know the surface temperature, and hence it should be a greenish star, or Abhijit should be a more like bluish star, would have been here. It is not a perfect black body, so the secondary part, depending upon whether it is a Arudra type of star or whether it is a sun type of Arudra type of star, will fall on this brownish line. The sun type of star or Abhijit will fall on this bluish star. So in a principal component analysis, the main thing is if you read off this B minus V value, you get the temperature, but then what they call the acceleration due to gravity in the surface and many other effects show deviation from there. So if you know the point, whether it is at this where I showed bluish in this, you know it is the sun. If you see it somewhere here, it is maybe more like Jesta. Already you know the crossing, etc. That is the kind of problem we will come across. I can't. Now the question is, a galaxy, a arecanut is not like a star, it is more like a galaxy. So it is a little more complicated, and also the typical galaxy, the surface brightness is less than the mean sky brightness. So these are the problems, almost one-to-one problem even for arecanut. But machine learning there, given these subjectiveness, etc., they started in the 1980s. Some of those papers you can see 1990s well established. So this is a 30-year-old or 35-year-old subject for astrophysics. So nowadays, any undergraduate student, for instance, here Professor Prasanna, our dean, gives machine learning artificial intelligence. If a student group makes a project, small project of 30 hours, they can easily do the Sloan digital sky survey where you have few million stars. Their classification with some 90% accuracy. So what we did, I will go quickly, technical thing I will avoid. So we got some 410 arecanuts from 2 distinct regions because we did not want effect due to one single region to affect. Then the thing is, immediately after harvest, they were brought The student, Balavamsi, did this first, manually classified into 5 distinct classes based on his eyes. This is a good, this is a bad, green, etc. Each areca nut is imaged over 4 nights over a 1-week period, because okay, in one thing there will be 200, you have to do it over 1 night, etc. So the various, nowadays you have nice libraries, so you can use it. And what your computer people will be more familiar, the hue saturation value. Let me just tell, this hue value alone will, for 70% of them, they will tell what kind of areca nut it is. But I am still uncomfortable with that. So when you do so, I will first show you the machine we did. This machine here, you drop the areca nuts, they just go. The mechanical engineers have easy way of getting one at a time going. Here is a infrared sensor. The moment your areca nut comes here, the infrared sensor drives a Raspberry Pi, and then your webcam is on. So as the areca nut moves from here on this belt, conveyor belt, the image is taken, it is recorded there, and later on, during the testing phase, by the time the areca nut reaches here, the classification is over, and here I have not shown the outlet. It will turn this also, depending upon out of the 5 groups which it is. So when you do that, the 5 types are shown here with their bounding boxes. These 4 are good types, but orientation will be different, and a bad one. So the various type of things are shown here. About 5% of them, less than that, 3 to 4% are the bad. So various types are here. So this is the essential setup. This is what. Now the thing is, if you were to plot this, I will try to finish fast. Then they are distributed like this in a 3-dimension. It is a 2-dimensional plane. Now the exact distance from this point up to here shows how much radiation you got. Maybe it is more shiny. Maybe your webcam on that day that was more light. But the angle, if it is this, it is green. If it is this, it is the red one that has to be dried, so on and so forth. But the main point is here the greenish yellow, and what you show here, the broken ones, they are not well separated. This is not clear from this diagram, but in the computer it is clear. Anyhow, the data analysis, we tried a number of things. I won't go much. If you take a logistic regression or a support vector, essentially one mean color, and I will finish first. And saturation thing alone is needed. Convolution neural network, we wanted to get this shape part, yellow has this, etc. It was not very successful, but even then we had some 95% accuracy in this. YOLO, it is still not in a very good position, but we want to work with that because continuous imaging and segregation without stopping, and we can do better with the color gradient in a future trial, we are hoping. So this was the essential work. Now the thing is to separate it out, principal component analysis. The present one, apart from on an image of your about 1200 by 700 pixel, you go through the mean color, the median, etc., and use them for considering a higher dimension, and then take the main dimensions there. So then you find that your green here, your red are well separated, and even the greenish things are reasonably nice, and a few, it is not clear here, these things are away from this main surface. So that is what we did. There are other methods to do that, but there we are trying to revise. But the main problem, you see, what we got earlier, September 1999. After that, because of COVID, we could not get a second sample to try certain part. Anyhow, so this is the thing, various types of green, etc. in the YOLO, the result. I don't think I should go very much into it. So the next, of course, the dehusking or peeling part. I am trying to convince our robotic expert who could see the amateur astronomical telescope and see immediately what kind of thing you can do. But he is reluctant so far. If he does go through the next peeling dehusking part, next time I hope I will be able to give you a complete picture. Any input from you people will be nice. So far about the segregation, I think we have done reasonable job. Thank you. My talk is over. Thank you.
Thank you, Dr. Narsiva. Dr. Dope, your microphone is mute. Please unmute it. Dr. Dope, are you there?
Professor Patel, I think you can take over if her internet is not good.
Right. Okay. Thank you, sir.
In case somebody has question, either you please collect. I can't see here.
Okay. Okay, conference delegates, if you have any question, just send me in a chat box that I will forward to Dr. Narsiva and he will reply to you. And you can also contact directly to his email that is shown right now on email in a screen, so that you can contact him. Dr. Dope, are you there? Okay, in that case, we'll call the second author of the second paper. So the second paper is of 73, paper ID 73, but they are presenting that paper by using pre-recorded video, and we have a little bit less time, so I will call the author of the paper ID 131, Dr. Vishnu Pendalia. Are you there, sir?
Yeah, yes, Dr. Patel, I am there.
Okay, just I am making you the presenter. Then you can share your
Sir,
screen. Yes, sir.
Sir Kanup Patel, sir, sorry for the inconvenience. There is some network issues are there because I'm connecting and disconnecting.
Yes, madam.
So,
No problem.
sir, please send me in the chat box if anything is there, because I need to ask the question, because there is a one question from my side, but if it is ended, then I will. I'm not going to ask that question, sir.
But right now, Dr. Narsiva is there. You can ask him.
Yes, you please ask me.
Actually, sir, your entire collection of the data to work on the accuracy of the segregation.
Yes.
Part.
Yes, about the accuracy, I told you, if we have our support vector machine or that CNN, convolution neural network, we can get 96%, 93 to 96%, yes, of now. It is just the orientation of the image that creates. But YOLO, the green is yellow, we still have problem. Part of the thing, I should confess, the student tried the standard deviation instead of gradient, which in the next round we are going to correct. But remember, above that 96% is not easy, because the greenish yellow, what we put, that is what I want to work a little bit, what our eyes will tell versus what the computer will tell will be different. We want to utilize it, then we may be able to tell. So we have a problem now. Part of it is because we started from zero. But if you have some more idea, you please send me email. I will try to answer my best. That is why I put that graph as it is, showing that greenish yellow, our result is still not satisfactory, but we know the reason. What eyes will tell, what the computer tell are not exactly same. It is a good thing, but we have to sort it out. Thank you.
Okay, sir. No, please, next author, please you start your presentation.
Yes, Dr. Petralia is there. I made him a presenter. So, sir, you can start.
Okay. Thank you, Dr. Patel. Thank you, Dr. Dhupe. Thank you, everyone. So my paper is relating machine learning to the real world, analogies to enhance learning comprehension. So the motivation is like this. A decade or two ago, software was increasingly becoming ubiquitous. So much so that it started getting included in school syllabus also, right? Today, the same thing is happening with machine learning. Soon it may appear in the K-12 curriculum. K-12 refers to kindergarten to the 12th grade. So there is a need to simplify the narrative, machine learning narrative, so that everyone can understand, more and more people can understand. There is also scope for incorporating more of the real world learning phenomena into machine learning by examining the parallels more closely. So this paper is in the direction of these two objectives. But the presentation is only a sampler. For more such analogies, please refer to the paper, and for even more, read the book that I'm currently working on, which will be released towards the end of 2022, next year. So we all know that the dot product of vectors, which we learned in high school math, inherently has the semantics of similarity, right? How close the two vectors are to each other. So in machine learning, KNN, support vector machines, kernel machines, these all use similarity directly, right? And matrix multiplications are essentially a series of dot products. So it can therefore be concluded that a significant part of machine learning is inherently learning by analogy. In fact, recent work proved that every machine learning algorithm that uses gradient descent, and that means it includes deep learning as well, is essentially a kernel machine. That means it works by similarity. So if you take the example of natural language processing, Word2Vec, Glove, Elmo, and the most recent BERT, they're all based on similarity. Human learning will be much more effective if it is based on similarity as well. We all experienced how teachers make a whole lot of difference when they explain the intuition behind a concept using similar examples instead of just explaining what the concept is all about, right? We all experience this in our childhood. So it is particularly important for advanced abstract topics like machine learning that we use real world examples to explain the topics, to simplify the understanding, to enhance the understanding. So let's get started. Here is the first such real world similarity. We know that supervised learning requires labels. The algorithm learn from labels just like children learn from the labels that the parents assign. The value system, the thought process, all that evolves in a child based on these labels that the parent assigns. Whatever the parent tells is good continues to be a value for the child, and whatever the parent tells back continues to be a value for the child. In a similar fashion, supervised learning model evolves based on the labels. However, with time, children change the labels that parents assign and come to better conclusions. So this is something that can be explored to improve the quality of annotations, quality of data. We already have semi-supervised learning and active learning, but probably we can think of ways for the machine learning algorithms to actually change the annotations, change the labels as well. So that is one takeaway from this. The next example, the next concept is the maximum margin classifier. We all know that support vector machines are based on maximum margin. So we can think of the classifier in this case like the judge in a court, an arbiter who needs to be impartial and be equally distanced from both parties of the dispute, right? The judge takes a softer approach sometimes, and that behavior is somewhat modeled by the soft margin support vector machine. So that the analogy of support vector machines is with an arbiter or a judge in a court. We all know that the performance of machine learning models, particularly the parametric ones, is impacted by bias, just like the performance of people due to bias, right? So here are some parallels between the two kinds of assumptions which result in bias. Probably the first one, the first row, is the most commonly understood, but we still do it for lack of probably better alternatives. So the first row says, in linear regression, we just assume that one line or a hyperplane fits all data points for prediction, which is a highly simplified assumption, right? Because it is very unlikely that all the points fit on a line, but still we use linear regression very popularly. Similarly, in real world, we often make the assumption that people of a particular gender or ethnicity or religion are all behaviorally the same, or the age group. So this is again a very simplified concept, right? A very simplified assumption, because people are too complex to be judged like that. They need to be properly addressed rather than just being grouped into a class. So these are some of the biases which result in huge errors in both machine learning models and in our real world experience as well. There are other assumptions, like in machine learning, we have this assumption that features of the data domain are all independent of each other. Independence is one of the commonly assumed assumptions in machine learning models, which results in a bias, and then it's a simplifying assumption, which will result in bias and therefore error. In real world, similarly, we have other biases like judging a person based on the first or the best impression and things like that. So, so there's a clear analogy between the real world and machine learning models here. The next analogy is between regularization and spirituality. In machine learning, we reduce the weights attached to features by regularization, right? We don't want the weights to be too high. Why? Because the big weights do not generalize well. We want smaller weights so that they can generalize well. In real world, we reduce those weights using spirituality. I'm pretty sure you all know the Sanskrit word hari, right? It essentially means to lose. Harna, right? In Hindi, harna, you say harna. It essentially means to lose. So hari basically means to reduce the importance we give to the happenings in our lives and thereby reduce their impact on us. So that is the whole idea of hari, right? And that is the whole purpose of Har Simran, right? In Punjabi, a lot of names. Har Simran is a very common name. And in Hindi, it's Hari Smaran. So it essentially means reducing the weights. We don't want to be too much attached to anything in this world. And spirituality helps in reducing those weights. So we are not too attached. We don't give too much importance to anything that's happening in the life. So that's the other analogy. So the hidden layers in an artificial neural networks typically do the intermediate work of classification, right? Eventually you classify. The artificial neural networks typically can be used for classification and regression, but here the example I am taking is classification. So eventually the ANNs are able to classify the data, right? But for the output layer to do that, the hidden layers need to do some work. They actually to some subtasks. For instance, if the problem is to classify an image as a car, some of them may learn edges, some of the hidden layers may learn angles, so on and so forth, right? That's how artificial neural networks work. So it is very similar to the real world concept of an organization, right? So all these hidden layers are working in tandem to produce the end result, just like in an organization where each department focuses on a subtask. So there's a clear analogy there as well. So we all know that quite a few of us are teachers, so we all know that students focus more on the mistakes they made in the exams than the answers they got right. That's how they learn. So they focus more on the mistakes that they made. So this is to make sure that they do not make the same mistake again. Boosting takes a very similar approach at learning. So it prioritizes misclassifications to eventually improve its classification. We all know that adaptive boosting, right? Adaptive boosting, what do? We prioritize the misclassifications so that those data points get picked more often, right? Same thing with student learning. So students try to focus more on the questions which they got wrong in the previous exam. Excuse me. So in the last icSoftComp conference, I gave a presentation on generative adversarial networks. And generative adversarial networks basically draw their inspiration from the game theory. And a particular game that comes to mind is that of Akinator. Akinator is a guessing game. You can Google for that game. You can actually play the game also. It's an online game. It's an interesting game also. So generative adversarial networks work in a similar fashion. Unsupervised learning, which is more recently being called self-supervised learning. I mean, what is his name? Jan LeCun, particularly wants unsupervised learning to be called as self-supervised learning because he thinks that without supervision, I mean, there should be some kind of supervision for learning. So he calls it self-supervision, which kind of makes sense. So unsupervised learning is all about, or self-supervised learning is all about discovering latent features, hidden features. People do the same thing when they grow out of their parents' upbringing. The first thing we probably do by ourselves is to make friends, right? And probably make groups of friends. How do we make friends and or form groups? We basically recognize hidden qualities of people. Why do we like a person? I mean, why do we befriend a person? Because there's something, a quality of the person which we like. Probably that quality is just like we see ourselves in looking at those qualities. So the idea is basically to recognize hidden qualities of people. And that is exactly what happens in clustering algorithms. Right? So data items are grouped based on their hidden or latent features. And that is the whole reason why self-supervised or unsupervised learning is so very powerful. Right? There are so many applications. If you take deep learning, a lot of applications are based on self-supervised learning or unsupervised learning. The reason is because these algorithms get the hidden features out. So that is the other analogy. And then principal component analysis. Professor Narasimha talked about principal component analysis in the previous talk. So what we essentially do in principal component analysis is look at the variables. And in caricature, we do something similar. The right side, you see, is not a true image of Barack Obama, right? Does not look like that, right? But we are still able to correctly identify the caricature. Why? A caricature focuses on the oddities, where the person varies the most from other people. In this case, Obama's cheekbones and the teeth seem to be where he varies the most. So the focus is on those. For that matter, Prime Minister Modi, you take Prime Minister Modi, his lips are shown as big in caricatures, his lips are shown as big and wide, right? Because that is where he varies the most from other people. The moment you look at the uniqueness, you can automatically identify the person, even if it's not the true picture. So
Dr.
that is the idea in PCA as well.
Sorry for interrupting, sir. Could you please conclude your paper in 2 minutes?
Okay, sure.
We have time limits. Sorry for that.
Yeah, no problem. This is the last slide.
Okay.
PCS captures the directions where the data varies the most. So that is exactly what we do in caricature. So we capture the variance. So those are some of the analogies that I had in mind for this presentation, more in the paper. And please feel free to stay in touch. My details are on the website, San Jose State University's website, and I am generally searchable on the internet as well. My Twitter handle is also on the slide. Please feel free to follow me on Twitter and other social media sites, LinkedIn. And if you have any questions, I'll be happy to answer.
No question from my side. If audience, they are having questions, they please ask.
Anyone has any questions in attendance? No question, sir. No question, madam. Madam, shall we move forward?
Sir, we can move forward, but there is one participant, Ratna Lata Gupta. She is waiting, but I don't.
She has a problem. I think she has a network problem. I tried to admit him. I tried to admit her, but I couldn't do that things.
Okay, same thing at my end also, sir. Okay.
So shall I call next presenter?
Yes, sir.
Thank you, madam. So next author of the next paper is paper ID is 142, and the author are Vaisali Kadam, Kalpana Khandale, Namrata Mahendkar. And the paper title is Text Analysis and Classification for the Pre-Processing Phase of the Automatic Text Summarization. Vaisali Kadam, are you there?
Yes, sir. Yes, good morning, sir.
Good morning. Just give me 1 minute. I am making you the presenter. Then you can share your PPT.
Yes, sir. Okay, thank you.
Dr. Pendale, I am making you attendee now.
Yes.
Yeah, sure.
Thank you.
Thank you.
सर ते प्रपोजल जे एंटायर आहे ना त्याच्या शेवटच्या पेजवर पण आहे ना रजिस्ट्रार चेअरमन ऑफ ट्रस्ट अँड बोर्ड मॅनेजमेंटची साईन लागते सर. त्यांच्या ऐवजी मग कोणाची सही घेता येईल का?
Vaisali.
Yes, sir.
Now you are the presenter and share your content.
Okay, sir.
हा कारण का कसं याच्यात
Shall I proceed, sir?
Yes, before that, I just that you need to conclude your paper in 10 minutes
Okay.
because of the time constraint. So
Okay, sir.
try to complete it. Thank you.
Okay. Thank you, sir. Sir, are you seeing my viewing my screen, sir?
No, madam.
Yes?
No, madam.
No.
Screen is not visible at all.
Okay, ma'am. Now?
No, madam.
Mm.
Just a minute. Let me show your PPT. I can share your PPT.
Sir, now?
No, madam.
La
One
idea.
minute. 1 minute. I am sharing your presentation file. Okay. I think we can see your.
You are viewing my screen, sir, now?
No. 1 minute.
Yes, sir.
Professor Patel, you have her PPT, isn't it?
Yes, I am doing that.
Ale zmieni się. Ale tak, no nie zakładam.
Yes, sir.
Okay. You can start, madam.
Okay, so good afternoon, good morning to all. So myself, Kadam Vaishali Punlikrao from Department of Computer Science and IT, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. My paper title is Text Analysis and Classification for the Pre-Processing Phase of Automatic Text Summarization, and the paper ID is 142. The next slide, please. And my research guide is Dr. C. Namrata Mendel, and we have completed this task under the guidance of respected ma'am. So these are the contents and outline for my paper. So we have introduction, literature survey, we go through methodologies, results, conclusion, and so on. Next slide. So first of all, introduction. So today's world, now we know that today's world is the world of internet and unlimited information resources are available due to digitizations. More informations are available and they are considered as the overload. So NLP is the field of computer science or subfield of computer science that all these particular problems they are related with the languages or human languages. So NLP makes the machine capable to understand the natural languages and manipulation of all these particular languages. As NLP is came in existence in early 1958, and from that we start the special type of study of the human languages. As human language is important or human language transformation and interpretation is important to improve the social and cultural standards so that we can share ideas and we can improve the actual status of the life. So mostly in general in universe the knowledge is available in the form of information, and all these informations are mostly available in the form of the written text. So under NLP, this text summarization is the important task or one NLP popular NLP problem that we have discussed, or researchers give more concentrations on all these types of problems. So next slide please. So next slide. So there are means when we go through the detailed study of this particular task they are considered under NLP. We researchers faces different types of problems that are actually the challenges to access the specific information, because a lot of information is available for a single item for the search. But when we go through, or if we want to have the very specific information regarding this search item, we have many difficulties for sorting the information. So sorting of the specific information is difficult, and it is considered as a challenge in the NLP or natural language processing. So designing of any NLP applications, because mostly under this NLP we go through different types of data analysis, then different types of particular applications like text summarizations, text mining, information retrieval. Corpus is important. So the to have this important informations, we should have to perform some computational processing. So under this, we need a corpus that should be in a standard structure format of the language. So we have to go through under this NLP task development, we have to go through various type of text analysis and the text mining processes. So text analysis is important for understanding the language and for generation of the language, and obviously this is based on the actual language morphology and the grammars and the rules of grammar of that particular language. As here in this paper we discuss the text mining or these particular analysis phases regarding the summarization. So summarization is a process where we tends to select important contents from the source and then represent them in a shorter version. So many times when we go through a particular single search item, single words means or they express many ideas in many contexts, and many times many context speaks the same thing. That means language is important to express the ideas and to have more communication. So in information systems, language always used to express meaning by language notation, and this is mainly depends on the actual instance of the communicator or the speaker exactly. So next slide please. So there may be various instances where the same words appears repeatedly or frequently. These repeated words are, or these frequently appearing words are generally called as the stop words. These stop words are common function words like article, preposition, conjunction, prefix or suffixes. They are coming with the actual language or integral part of the language. But in general, these stop words are do not affect the overall idea and the meaning of the particular text, but they are the supporting ones. They are required in the text, and they are generally used in the different types of language generations. So they have their own particular importance. But in case of some particular information retrieval and data mining application, this removing of stop words gives a better result, and they reduces the actual particular size of the particular text or the particular source. So in case of information management and memory management concept, removing of stop words reduces the actual index files, and they supports for handling the memory management and the time constraints as they acquire. Means these are the unrelated or unrequired informations coming with the actual language. So removing them is better and good for memory management. So in general, in natural language text manipulation and the particular systems, we have particular importance of this pre-processing. Means before performing the actual process or computational processes on this particular language data, we have to go through some basic analysis. But these are too important to understand the or to get a desired particular output. So in processing we have go through different types of text analysis, text cleaning, text annotation and text normalization. So text analysis is based on the actual morphology of the language, whereas it is based on the grammar and the understanding of the language itself. Then text cleaning is one of the important particular operation, basic operation, that is considered under the pre-processing task, and under this we go through the removal of the stop words and such type of the operations. As text annotation is important, this is important to have the particular to generate and to specify a specific meaning for the actual language words. Like pause tagging is the best example we discuss under this text annotation. And lastly, we have this text normalization. Sometimes some unwanted data or some particular suffixes and prefixes appears with the original base particular word, and they are important to generate some meaning, but again they create some problems if the existing words are appear again and again. Like in stemming we do removing means we do the removal of the suffixes, and then we get a base word that will be sufficient or efficiently handled throughout the actual linguistic computational processing. So in this case, we have to go through the pre-processing phases that are important in natural language, in text management and the computational development. So next slide, please, sir.
This Kadam,
Yes, sir.
I request you to complete your 15 minutes.
Okay, sir. Okay, fine. So next slide, please. So here we do
Just come
the.
to the main your work, research work.
Okay, next slide, please, sir. Then. So. So we use here means in overall our development we use our own particular set of stop words. We are define these by our own and using the grammatical and language rules, because there are two concepts. That means there are some online tools are available, and the dictionaries are available. They have their own particular set of these stop words like Kaggle and RL and LK. This available online, but mostly this RankNL and Kaggle, they have developed their systems. They have their own stopword set, but instead that sometimes when we observe, when we go through the machine learning concept and we want to train our system for particular ones according to some language and grammatical rules, we can able to develop on dictionary. So in this work again we use some stop word identification rules and develop our own corpus or 300 and more than that particular words collection for this work or proposed system. So next slide, please. This is the general architecture of our proposed system. So this is go through the 5 different phases. We have the input Marathi text. This is the first phase and first stage. Here we accept input in the form of Marathi, or it is written in a Devanagari script actually. Then we go through the input, go through the some particular processing, and we perform the pre-processing of these particular input text. Under that we go through the sentence tokenization, word tokenization, and under this sentence tokenization we separate the sentence wise data, means whole the paragraph is split into number of sentences, and then after that under word tokenization we separate the whole sentence according to the separate words, means individual words are appear separately. And suppose if we have one sentence, my name is Vaishali, so the word my name is Vaishali. These four particular tokens or lexicons are separate out and they are separated with the commas, and we do this task using the analytic app and the sentence tokenization, word tokenization function. And after that using the dictionary and the rule set we go through the stop word removal, and for that we use one algorithm. So we take and select one specific word from the text, individual word from the actual text. Then we go through the we check this particular word with the whole dictionary and the corpus, and through is using the similarity concept we compare this word with the text. If the word is matched with the stop word dictionary list and the word from the dictionary list, then we called it as a stop word, and then whole the appearance of this particular word is removed from the actual source. And if the word is not similar with the actual stop word list, then we go through the selection of the next word. And in this way, using the dictionary and the rule set, we perform the removal of the actual stop words from the particular corpus. And finally, we get a standard Marathi output text, which is the text that we have appeared after removal of the text. And we find that, so next slide please.
Ms. Kadam, please conclude in 1 minute.
Okay, sir. Okay. So under that we have I given here one example. So we have input, then we have this text sentence tokenization, word tokenization, and then after removing of this, we get some particular desired output like Geeta davi shiknari, Ushachi hushar mulgi. So these are the themes and main ideas or the related concept we get after removing of the text. Next slide, please. The next slide. So this for our training data set we use 25 online Marathi stories, and from that we get this particular percentage of the removal for the stop words. So next slide please. So the conclusion is after this completion of the overall task, we conclude that stop words removal is an important concept of the pre-processing concept under discussed under the NLP
For
task.
30 seconds.
Yes, sir. So there are various words in Marathi. They are frequently appeared as by a default nature of the language. But removing of these stop words enhance the system performance, as we are able to reduce 34 or 30% of the data from the original source. There are various other languages like Kokani, Hindi, Punjabi, and Gujarati. They are also using the Devanagari script, but they have achieved more success for this type of preprocessing tools. But again, still in still today, there are some lack of this particular information system and the tools for Marathi. So this is one of the tasks. This is also considered under the NLP problem. So to achieve better accuracy and to have design a specific particular tool for the Marathi language, we use rule-based supervised machine learning approach for the Marathi, and our system gives average accuracy calculated at the 32.62 of the overall work, and it exactly improves the performance of the information retrieval system and the data mining for the overall corpus. So in the future we have to concentrate on the enhancing the database and increasing the size of the text with list of the stop words, because again there is no particular such Marathi stop word list is available or that having the standard, and again that covers all the language words. They are considered under stop word in the Marathi language. So next slide please. So for overall this particular task, my department
Stop.
of.
I am stopping your PPT.
Okay, sir. Thank you.
Okay, I think Dr. Dope, it's your turn. Dr. Dope, are you there?
Yes, yes, I am here. Madam, can you tell me how many words you have taken for the data set?
Ma'am, I have taken 300 words. They are developed. They are selected from my particular documents that we have considered for the development, means on from the own database, and using the morphological analysis and the grammar rules, we find that these are appearing again and again. So if we remove them, then it obviously gives a better result for us and able to reduce the text up to 30% and more than that. So in text summarization, there are again different types of concept, like sometimes we can construct a story or construct a whole document with some specific theme, and for in such cases or in such application also, this is the main idea that we use. This particular removal of the stop words is important. In case of extractive summary, there are two different concepts of summarization: extractive and abstractive. In extractive summarization,
Okay.
it gives a better performance.
Okay, madam, it's okay.
Thank you, ma'am.
Okay.
Thank you, Ms.
Next.
Thank you, sir, for organizing this conference and again giving me chance for the presentation. Thank you for all things.
Any comments, madam? Dr. Dope? Madam, are you there?
Sir, I am here, sir.
Okay, so I think you just conclude this session.
Okay.
All papers are presented. Only one paper is there, but it's a pre-recorded video, and we don't have that much of time, so we skip that video. If time permits, then we'll play that video later.
Okay. Okay, sir. Okay.
Any comments or anything, Dr. Kulbi?
No, sir. So, in fact, I want to give a suggestion that all the papers which are presented in this conference, all of the paper titles are very nicely, and those are taken care of the societal issues. So I'm very much thankful to you, sir, for organizing this conference which deals with the societal issues.
Thank you very much, ma'am, and thank you also for sparing your valuable time and chairing this session. Thank you very much, ma'am.
Thank you, sir.
Doctor, are you there, Gayatri madam?
Yes, I'm there.
I'm just making you the presenter. Just give me 1 minute.
We have, I think, 4 papers, right?
Yes. 2 are presenting live and 2 are having a pre-recorded video. We need to complete in by 12 o'clock.
Yeah, that's okay. We will finish by 12. Who is any pre-recorded or all 4 live?
No, only 2 papers are live.
Okay.
Most of the 2 papers are presenting their presentation live.
Okay.
So I just call them.
Yeah.
Do you have the schedule?
Yeah, I have the schedule 148, then 96.
So 148 is a pre-recorded.
Okay.
96
then
is a
96.
Live.
Then 208
is a pre-recorded.
And then 81
is a live. So you can call the author of 95 and 81.
Okay.
And if time permits, then we can cover the 148 and 208.
Okay, done.
So Dr. Dope, Doctor, welcome to you in this technical session 2. And this Dr. Gayatri Doctor is working as a professor in a SAPT University, and her research area is using artificial intelligence and machine learning for the urban technologies. So I welcome Dr. Gayatri Doctor, and I hand over to you to chair this session.
Thank you very much, Dr. Patel. And it is a privilege to be here and be part of the icSoftCom conference. So today's session is the second technical session. Yes. And we have 4 papers where 2 papers are being presented live, that is O96, mining spatio-temporal sequential patterns using MapReduce approach, and identification of barriers in adoption of IoT commercial complexes in India. So I would like to invite both these speakers. The other 2 papers, which are weighted hybrid recommendation system using singular value position and cosine similarity, and the radial basis function network based intelligence scheme for software quality prediction. These two are being presented. They are the recorded sessions. So I would like to invite Sumanlata Saleti for presenting her paper, paper number 96. Is she present over there?
Yes.
ma'am.
Yeah. So I'm making Dr. Saleti as a presenter.
Right.
Just a minute.
Can you make me the presenter like
Yes.
96
Now you are presenter, so you can share.
And is the second person also over there, Nishani?
Author of paper ID 081.
Hello, sir.
Yes.
Can you make me the presenter for the 096?
What's your ID?
096 Radhakrishna.
It's not like here in team ID. I make the Dr. Saleti as a presenter. Are you the co-author?
Yes, sir.
What's your, like you are Radhakrishna?
Yes, sir.
Okay, just a minute.
Hello.
Okay, I made you presenter.
Yeah, I got the access.
You can share your PPT and start presentation and try to complete in 10 minutes.
Yeah, sure. Is it visible?
Yes, your presentation is visible. You can play that.
Yeah. Hi, everyone. So the authors are from SRM University, Andhra Pradesh. So our research is about mining spatio-temporal sequential patterns using map-reduce approach. So now I will be covering introduction, existing algorithms, problem statement, and the two proposed.
Intervene, sir. Sorry for intervening. Just play your PPT.
Okay.
Thank you.
So today I will be covering introduction, existing algorithms, problem statement, and the two proposed algorithms, experimental results, and the conclusion. So firstly, spatio-temporal data mining. So what is spatio-temporal data? Spatio-temporal data is nothing but which deals with space and position that evolve with the time. So it has two or more dimensions. So now the spatio-temporal data mining means discovering the patterns using these spatio-temporal data. So let's take an example like the buses will be moving along the series of streets from one place to another. So here the spatio-temporal data means the bus is located in this position at this particular time. So from this data we will be discovering the sequential patterns. So from these sequential patterns we are trying to predict the past and future movements of the objects. So from here, sequential pattern mining is a data mining task for analyzing this sequential data and discovering the sequential patterns. And this first, the spatio-temporal data mining, first the DFS mines the first algorithm to find the discovering the frequent sequences from spatio-temporal data. So it is a depth-first algorithm, so which usually scans the whole data set to find out a particular sequence, particular output sequence. And nextly, Messiac proposed a breadth-first minor algorithm to find the significant sequential pattern and also the topmost sequential pattern with participation index greater than the threshold. And also he came up with a solution like SP tree structure, so which helps to reduce the time for finding out a sequential pattern. So here the limitations are like the existing algorithms all has been processed in centralized approach. So here we came up with a distributed approach by using map reduce approach. The problem statement is like firstly we will take a data set of event instances residing in a Hadoop distributed file system. So we have used the crime incident Boston dataset, and also we have to specifically give some thresholds like spatial threshold, which means radius, time threshold, which means the time frame that we have to set up, and the participation index threshold, which will be given by the user. And now the from that, by using these thresholds we will be finding out the sequential pattern. So the proposed algorithm will be having two-phase approach. The first map reduce phase approach will be having will generate the spatio-temporal sequential patterns of length 2. In the second phase, it will generate the sequential patterns of length more than 2. So in the first phase, the inputs are like the data set that we have been used, and also the neighborhood, which means the R and T, which the user will be giving, and the event types. Event types like let's take I was saying like there is a patterns we have to find. So let's suppose A gives rise to B is a pattern. So A and B are nothing but the event types. So and the significant threshold participation index will be set is also be given as the input, which is theta. So the output of this first phase is like finding out the sequential pattern with length 2. So what the mapper method will be doing is like find the time and space proximity between the two events A and B, and also we will be giving the neighborhood so that we can get the instances that are involved in that neighborhood. And the mapper method will emit the output in key value pairs. So the key here is they emit the event types of length 2, and the value here is the neighborhood instances. And now the reducer method will be getting it as at the input. And now here we will calculate the participation ratio and participation index. So what is participation ratio? So participation ratio is nothing but the instances that are involved in the sequential pattern divided by the instances involved in the whole data set. So for the length 2 patterns, so the participation ratio and index are same. So we will store the length 2 sequential pattern in distributed cache file only if the participation ratio satisfies the threshold given by the user. So now the output of the first phase will be given as the input to the second phase. So here the output of the second phase will be like the length of the pattern, length of the sequential pattern, which is more than 2. Here the mapper method retrieves the patterns of length 2 and store it in a H, and also create a data structure L to store locally generating the patterns, so that we can let an E be the entry, means like the pattern A gives us to B is an entry E. So we will emit the E and split it into events. And also like as I said, the mapper method is like a key value pair, emits the key value pair. Here the key is splitting it into events, and neighborhood are the value pair. And here we have only the pattern length of 2, so A gives rise to B, so we have to
Dr. Radhakrishna, you are not audible.
I mean, we've lost.
Sir, are you there?
I think his network must have dropped.
Yes.
$96, it shows, but
Yes.
I'm
I
very
think he's
sorry.
disconnected. Huh?
Yes.
I'm very sorry for the interruption.
Yeah.
There
Okay.
is an issue. Able to see the slides, right? Presentation.
Yes, you may continue.
So there is a pattern A gives us to B. So we have to find whether it can be extended or not. So that we will check the instances that are in the H here. So if that satisfies, you can see the algorithm. It can be extended if A gives rise to B gives rise to C. So then it will be generating the length more than 2. And now we will be passing it to the reducer method, and which checks the participation ratio and participation index, whether it is satisfying the participation index given by the threshold. Yeah. And next thing is like SP tree, uh, spatio-temporal breadth-first minor SP tree using. So what does SP tree differ from is like differ from the breadth-first minor is like uh, whether there are the event types will be in the T data structure, so that the pattern can be extended by using the children of the uh, first parent of the sequential pattern, whether it can be extended or not, so that we can the sp2 uh, comes into picture because it reduces the generation cost, and also the reducing the time complexity here. And the most important thing is like finding out the topmost significant pattern. So what is topmost significant pattern? A sequential pattern is the topmost significant pattern if there exists n-1 patterns in the top set with participation ratio greater than or equal to participation ratio index of the particular sequential pattern. So to satisfy this, there are three conditions to satisfy. If the number of patterns in the top set are less than or equal to n-1 in the n-1 patterns, so then we will add it to the top set, and we will calculate the threshold, whether we have to change it to the highest one or not. And next condition is if the top number of patterns in the top set is equal to n-1 patterns, so we will add it to the top set, and we will change the threshold to the which is new sequential pattern participation index. And there is another condition. So if the top set is equal to n patterns, so the new sequence which is coming into the picture, which if it is having the participation ratio greater than the topmost one, so then we will replace and delete all the patterns in the top element so that we can get the topmost significant pattern from that. And coming into the experimental results, like we have used the Boston dataset, which is having almost 40,000 crime in real related incidents and 26 crime events. And we have compared two algorithms, MapReduce spatiotemporal breadth first minor and MapReduce SP3 spatiotemporal breadth first minor, and with their execution and number of sequences discovered. So we have changed the neighborhood. Here we can see R equal to 200 and T equal to 10. So R is radius and T is time frame. We have changed, and we calculated for those two algorithms. And as the participation index goes on decreasing, the number of patterns and the execution time has increases. And we have changed the values, and here R equal to 300, T equal to 8. And here also the participation index goes on decreasing, the number of patterns and execution time increases. And this is for another value of neighborhood. And here for finding out the topmost k patterns, we have set it to k 52 to 50. So for these two algorithms, SPT is getting in very less time. Like the execution time is very less for the SP3 breadth first minor. And well, coming into the conclusion, MapReduce spatiotemporal breadth first minor, we came up with a new MapReduce algorithm to find out the spatiotemporal sequential pattern. So the existing works are all in centralized approach. So we came up with a distributed approach. And here we have used SP3 algorithm so that we can reduce the generation cost of the candidate patterns. And also we have find out the topmost K mining approach used to find out the topmost sequential pattern in both the algorithms like SP3 and breadth first minor. On an average, the SP3 breadth first minor achieves 21% improvement than the naive breadth first minor with respect to the execution time. So as a future work, we would like to extend the MapReduce algorithm to generate the closed sequential patterns. And also we have proposed it can be, and also the proposed algorithms can run on multiple datasets to improve their scalability. And these are the references we have used to prepare the PPTs. Thank you, sir. Thank you, sir.
Okay. Thank you for the paper. I have two questions. One
Yeah,
is
sure.
you have said that you have used Boston City's crime data,
Yes,
correct?
yes, yes.
So where did you get that crime data from? From where did you pick up this crime data? That was one question. And the second question, after you have done your mining on this spatiotemporal on
Yeah.
this data using your MapReduce approach, what were your findings, let us say in layman terms? What did you infer on the crime data? Right?
Yeah. Sumalata ma'am, would you like to do any comment on this?
Yes. Uh, Good morning, ma'am. This is Sumalata, the co-author of the paper.
Yeah.
Yeah. So Boston dataset is publicly available. We have even included the, reference of that. We have taken
What I meant was, did you get it from GitHub or did it get it from the open data portal of Boston City?
open data portal.
Okay, fine, done. Yeah.
And then coming to the inference,
Yeah.
so we have executed our algorithm on 3 different types of radius and time intervals, and we
Right.
found that for less value of r, that is for r equal to 200 and the time is equal to 10, means for less r and more t, the execution time is of the algorithm is more and the number of patterns generated are more. So we have done for 3 values, r equal to 200 or t equal to 10, that is one thing, and another one is r equal to 300 and t equal to 8, and the third one is r equal to 300 and t equal to 4. Among all these 3, we found that in general for r is equal to less value and time is equal to...
This is fine. This is fine. But how do I correlate this to the crime? You said crime data, right?
Yes.
So how does this correlate to crime? Does it indicate you are having more crime, less crime? Is there any such correlation that has been done? That is all that I wanted to ask.
Yeah. So as the number of patterns are high for r equal to 200 and t equal to 10. So if
That's fine.
Can I comment on this?
Yeah.
Yes, go ahead, rather.
So actually here the crime incident, so we are finding out a particular pattern, right? So every crime incident will be having some patterns. So if there is any future crime incident happens, so we have to investigate, right? So that with the help of this sequential patterns, we can like predict the future movement of the crime.
Okay, fine. Thank you. Yes. Thank you. I think you can stop sharing now and we can move on to the next paper presenter. That is Nishani Salvi. She's going to be is she there? Nishani, are you there?
Yes, ma'am.
So her topic is going to be on the identification of barriers in adoption of IoT commercial complexes in India.
Yes.
Yes, Nishani.
1 minute.
Yeah. Yes, sir. You'll have to give her rights to present.
Yes. Now I think she is a presenter.
Can you see my screen?
We can see a calendar just now.
Yes.
Just a second. Okay, can you see my screen now?
Yeah, go into the presentation mode.
Yes.
Yeah.
Okay, so good morning everyone. My name is Nishani and I'll be presenting my topic, which is identification of barriers in adoption of IoT commercial complexes in India. So coming first, let's go to the background and need of the study. So the basic idea is that the IoT nowadays is a widely emerging field and every single person is connected somehow or the other, directly or indirectly, is connected to IoT. Maybe they will be using some wireless networks or some sensors in their daily lives. So IoT is a widely emerging field and it is in many sectors like educational, health, agricultural, and even in construction industry. And the main advantages of having IoT in specifically in a building is the inhabitants' comfort. It majorly focuses on the comfort of their inhabitants. Even your time, your energy, everything is saved if you adopt IoT. And also the healthcare and safety perspectives are also taken into consideration. So coming to the example, there is one example which I have taken, that is the Edge, which is situated in Amsterdam. So the building is smart enough to know your daily chores. So where you stay, where you come from, which is your car. It'll also help you to find a parking spot. So the system knows about your schedule, and it will help you to identify where to park your car, where is your workspace. So there is no allocated workspace to its inhabitants. The system itself assigns you a work desk. So this is how a smart building, an example it is. Also, you can, based on your preferences, your temperature and lighting can also be adjusted. So why was there a need to research on this topic? So because of very less number of projects currently in India are using IoT, and the benefits and barriers are not yet known up to its full extent to all the stakeholders. So hence there was this need to study the advantages and as well as the barriers which are faced while adopting IoT in different buildings, and also to know the awareness among the users as well. So the objective was to identify different technologies which are being used currently, as well as to identify the barriers and awareness of the stakeholders which are currently using as well as not using the technology. And also the benefits of using IoT was determined. So that these are the four objectives of the study. Then the scope of work was limited to Ahmedabad, specifically to one city, and three different other cities were also considered. And the type of building considered was commercial building. So basically, the main aim was to identify what were the different type of technologies used in these complexes, as well as the barriers and awareness were also identified. So the data collected was basically different types of technologies used in commercial complexes. So the study was first microed down to commercial complexes. Earlier, it was a wide area. So which were the projects where the IoT is currently being used, the barriers faced by different stakeholders, be it designers, engineers, PMC, contractors, and also the awareness was identified. So this was the methodology that was adopted during the study. That is, the methodology is divided in three stages: literature review, data collection, and data analysis. Literature review. So the literature review had a deeper understanding of the journals, conference proceedings, and case studies. So various papers and conference proceedings were studied, and different application of IoT in different buildings, residential, office, hotels was identified. And these were the major technologies that were used in these specific three buildings: home automation, health and safety, security, lighting and air conditioning, temperature. Wearable devices were majorly used during the construction process. So these were the few technologies that were identified in literature review. Then coming to the data collection. So first of all, this first step was to do a case study of commercial complexes. So the four case studies that were selected were, the first project was Shapath 5, that was in Ahmedabad, Intel SRR3, that was in Bangalore, and Voltaire, that was in Hyderabad, and Siemens in Mumbai. So these were the four case studies where I studied what are the different IoT technologies used, what are the barriers, who all stakeholders are involved in this project, and similarly based on their experiences and their barriers, further quantification of the study was done. So later on, after the case study, semi-structured interviews were conducted where the barriers were identified, and later on the surveys, semi-structured surveys were also floated to different stakeholders where their awareness was also identified. So coming to the semi-structured interviews, once the barriers were identified, I categorized them into three sections: technical barriers, financial barriers, and miscellaneous barriers. So technical barriers usually included of data security, compatibility, interoperability. So many users were facing challenges of they weren't sure whether their data will be safe or not. Since you are using IoT, everything will be on cloud or on the internet. So they were a little bit concerned and skeptical about floating or going using their data on the internet. So that was the main reason of main barrier that was faced. Then there's compatibility issues. Not all are using advanced technology. Some of them were using an older version of the system. So a compatibility was also a major issue. Interoperability, unpredictable actions of sensors. So sensors do need maintenance, and they were a little skeptical of about the maintenance of the sensors as well. The financial barriers were investment, maintenance. Since not all are aware about the IoT system. So the prices of the sensors are high. So they were a little bit skeptical about investing in the sensors or investing in the technologies as well. And then coming to the miscellaneous barriers, consumer awareness is a major issue. That is, not everyone is aware about IoT. So it did created a barrier in adoption of these technologies, as well as the high expectations of the consumer. And since there are no solid guidelines on IoT, there are greater chances of having some mishap while you are adopting these technologies. Then coming to the data collected, so this is the data or a graph which I made based on the questions which I floated, or people's perception survey, I would say. So I floated a people's perception survey on 104 different people which were involved in IoT, IT services, or they weren't using IoT or IT anywhere in their offices. So the first question was, are you aware about the implementation? So out of 104, 79 people were aware about it. And the other question as well, whether they were having a fiber connection or Wi-Fi or broadband at their office. So majorly of them had Wi-Fi, or they were using a fiber connection. Then coming to another question, that is, are they using any of these technologies in their offices? 74 people were using their technologies. Then coming to the domain awareness, whether they are aware of the domain where IoT is used, say safety and security, CCTV, temperature control, lighting, smart parking, fire, or none. So I would say almost 80% of people were aware about safety and security and CCTV where IoT is adopted. And then coming to the lower, that is 60% were aware about temperature control, lighting, and smart parking. So the main reason behind using
Miss
consumer
Sarvi, sorry
awareness.
to intervene you.
Sorry?
Please conclude your paper in 2 minutes.
Hello?
Miss Salvi, sorry for
Yes.
interviewing you. Please conclude your paper in 2 minutes.
Yeah, okay. So the major reason to identify the domains were to know about the awareness of the users. Similarly, a likelihood rating and usage agreement rating was also conducted. And based on these, a correlation method was adopted. So data analysis had semi-structured interviews, people's perception survey, and frequency of barriers. So these are the technical barriers where a percentage, I have shown it in quantitative form, which says 80% has data security, and interoperability was 52%. So these were the major challenges faced, and all the challenges that I discussed previously are quantified over here. Then finally, the conclusion was that consumer awareness has the highest frequency, which was followed by investment and maintenance of the sensors. So the barriers were quantified, and the major barrier faced was consumer awareness. Then the data analysis was done, that is the correlation method was carried out, and awareness was done on 4 factors. So the first was awareness and age, where the null hypothesis was accepted, which showed that the negative R value. Then Awareness and usage was another factor for correlation, which gave a 0.10, a positive R value, which means neither the technology, the usage of technology does not increase with the increase in awareness. So they were correlated. So all the four correlation factors, that is awareness, agreement, usage, and age, were correlated with each other, and the final answer or the final conclusion obtained was that all the factors are not correlated with each other, and it can vary based on the usage or based on the awareness of the users. And then what are the final benefits of using IoT? So there are two direct and indirect benefits. If you use your IoT directly, the operating cost will reduce, energy saving, we will have a lot of reduction in energy and water saving as well. And in indirect benefits, the occupant's comfort is a major benefit, as well as the health and safety and reduction in environmental impact and increase in productivity. And the final benefits of using IoT are, as I already discussed. So all of these barriers and people's perception survey was carried out on stakeholders as well as normal layman people who were not connected with IoT in order to understand their awareness and the barriers faced by them. Thank you.
Thank you, Nishani, for your paper.
Thank you, ma'am.
Does anybody have a question? Okay. No questions. Thank you. So, Dr. Patel, would we like to do the presentation of one of the
Yes. We can play
Nishani, you can stop sharing.
Okay.
Just a minute.
So we have 148 and 208.
So we'll play the pre-recorded video of 148.
Okay.
Just a minute.
Yogesh and Nilay. Okay.
Sanket, are you there?
Yes, sir.
Okay, I'm making you the presenter.
Okay.
So if any questions come, then you need to answer them.
Sure, sir.
Just a minute.
No audio.
Just a
Dr. Patel, there's no audio. Ah.
I forgot one thing. That's why.
Hello everybody present here. We are delighted to share our work on this platform. The title of our paper is Weighted Hybrid Recommendation System using Singular Value Decomposition and Cosine Similarity. So why recommendation systems? As we all know, a colossal amount of digital data is available now freely. This causes the problem of information overload, and simple search engines won't be helpful here as they simply return all the items matching the query, which leads to irrelevant data. Recommendation systems comes to the rescue as they bring with them a factor of relevance and personalization with them. Now let's talk about different types of recommendation systems. There are various types of recommendation systems, but here we will be talking about two, content-based filtering and collaborative filtering. Content-based filtering calculates similarity between items. That is, if a user has read an article, then all those articles similar to the original one will be suggested to the user. On the other hand, Collaborative filtering calculates the similarity between users. That is, if two users have read multiple common articles, then the system will identify both of them as similar, and new article read by user 1 will be suggested to user 2. Now, let's talk about hybrid recommendation systems. Just like this feature over here is made by combining multiple animals, a hybrid recommendation system is made by combining multiple RS. There are several different types of hybrid recommendation systems, but here we will be talking about two, which are cascaded hybrid systems and weighted hybrid systems. A cascaded RS follows a stage process. That is, the output list produced by the first RS is given as input to the second RS, which then refines the list and produces the output. On the other hand, in weighted hybrid systems, each RS is assigned a weight. Final scores are calculated for every item, and the items with the highest scores are presented to the user. In this slide, we will be discussing about our contribution. We have proposed a weighted hybrid recommendation system that employs a content-based filtering technique and a model-based collaborative filtering technique. The CBF technique uses cosine similarity along with TF-IDF factorization, and CF technique uses singular value decomposition. We have then compared our weighted hybrid with individual CBF and model-based CF techniques. We have also compared it with a simple cascaded hybrid system that uses CBF and CF techniques. We have then evaluated our weighted hybrid on two parameters called personalization and diversity.
To start with the experiments performed, we have initially implemented the algorithms that are previously discussed. For content-based filtering, we are using cosine similarity, which is a method to find out similar movies on the basis of certain keywords such as cast, movie genre, and the director of the movie and the name of the movie. A similarity score is calculated for each movie with another movie, and then that score is sorted in ascending order to predict which is the most similar movie, and then we suggest that movie. So the formula of cosine similarity is cos theta equals to a dot product b divided by the magnitude of a and b. So it's basically the formula of cos, and a and b over here represents the vector after combining all these features. For the model-based collaborative filtering, we are using SVD approach. In SVD, it is basically a dimensionality reduction technique. So what happens that we have initial matrix of what each user has given the rating to every movie. Now that matrix is being decomposed into three sub matrices, which is basically the dimension reduction, and then those matrices are multiplied again to obtain the new matrix. And in the initial matrix, we might have some non values or null values, but the matrix obtained will be the most closest similar matrix to the parent matrix. And this new matrix does not have any null values. Another approach is the cascade hybrid recommend system, in which the list generated by the content-based filtering is passed to the collaborative filtering in order to just refine the list in terms of the order. Next, explaining the methodology proposed of weighted hybrid system. Initially, to implement a content-based filtering approach, we have a metadata which contains keywords, cast, directors, and genre. All these features are combined to form a soup of the metadata. And this soup is passed to a TF-IDF vectorizer, which generates a TF-IDF matrix. And on that matrix, we calculate the cosine similarity and store the results into the weighted hybrid system. Next, to implement the collaborative filtering, we have a rating small dataset which we are using to train the SPD model. And again, the results are passed to the weighted hybrid system. The most important thing to note over here is these weights. These weights are actually used to set a priority to each of these algorithms. By doing so, we get best of the both worlds. And addition of these weights equal to 1. So basically, this acts as a bar of priority or uh, priority that we want to set to each algorithm. Like if we want CBF to have more impact or more flavor or more priority in our recommendations, then we can set a greater weight to CBF. In our experiments, we found that assigning 0.6 to CBF and 0.4 to CF gave the best results. Now, over here, the user ID and movie ID are used to trigger these model to generate the recommendation list that is required. Now explaining what we've discussed in a mathematical way, the input are I, movies watched by the user, J, the rest of the movies, U, user ID. The function of weighted hybrid, Wij is as follows, where W1 is the weight given for the cosine similarity, Sij is the similarity between the movie I and J, plus W2, which is the weight given for the SVD model, and Puj is the predicted rating by the user U for the movie J. Now, this PUJ is a normalized predicted rating. As the rating of movies are generally given from 0 to 5, we divide it by 5 to bring it to the similar range of 0 to 1 as Sij. Next, as we have already discussed that the sum of the weights is equal to 1, we can say that W2 equals to 1 minus W1. The variation matrix used in our experiments are as follows. Root mean square error and the mean absolute error was mainly used while training the SVD model. Now coming up to the most important metrics in terms of evaluating a recommended system. First one is the diversity, which means the dissimilarity between all the pairs of movies present in a generated list. So by explaining with the help of a formula, over here Sij is the similarity score of each pair divided by 1 by 2 n into n minus 1, which is basically the all possible combinations, and this is subtracted by 1 to give the dissimilarity, which results in diversity. Next, personalization. Personalization is the dissimilarity between two different lists generated for two different users.
Let's look at the results generated by our experiments. First, let's talk about the content-based filtering results. As you can see, the recommendation is generated for the movie Dark Knight. Though there are movies which are related to Batman, there are some movies which don't have anything to do with superhero movies or Batman movies. The reason is that we've incorporated features of movies such as director, cast, and crews together with the genre, keywords, and plots. This makes the list more diversified. But still, the over-specialization problem is there because the list generated for all the users will be exactly the same since we are not incorporating the user's behavior or the quality of the movie at all. So there are movies like Batman and the Red Hood or Batman Returns, which are Batman movies, and therefore they are in the list. But in terms of quality, in terms of rating of the movies, they don't have that much high rating. And therefore the personalization score is 0 because the list is same for all the users. So let's talk about the collaborative filtering model. What we're doing here is we selected 30 random users and we calculated the diversity for the recommendation list generated for all of those users. And the average diversity came out to be 0.98, which is very high. And what this does is it creates a sense of randomness and irrelevance in the recommendation list generated. As you can see that in this list, movies are not similar to each other at all. Very less similarities there between these movies. And that's why the diversity is very high. But this ensures that there is personalization. And therefore, a 0.7 personalization was calculated in collaborative filtering, which means 70% of the movies are not same in the list generated for two different users. But still, the new item Kosa problem is there, and the stability / plasticity dilemma still persists, which makes the CF less reliable. Next, we'll talk about the cascaded hybrid recommendation system. It takes a list generated by the content-based filtering and refines it using collaborative filtering. So what we're doing here is simply finding the relevant movies to the given movie and then reordering those movies on the basis of the user's preference. As you can see in the example, a list was generated first for the content-based filtering done on the Dark Knight movie, and then it was reordered for the user number 50 on the basis of the estimated rating generated by the SVD. So even though Inception, Memento, The Prestige have a lower similarity score than the Dark Knight Rises and Batman Begins, they are still higher up in the list because their estimated rating was higher. Now, cascaded hybrid recommender system suffers from the same issues that content-based filtering was suffering from because at the end of the day, it is the same list, just reordered. So the personalization for cascade hybrid recommender system is again approximately 0, and the diversity calculated for 30 random users, as you can see in the graph, is at constantly 0.85. Now, because all the lists generated for all the users are same, just reordered, the diversity is not changing. Now we'll talk about the weighted hybrid recommender system one, the one we propose in our paper. As we talked earlier, the content-based filtering has been assigned a weight of 0.6 and the collaborative filtering has been assigned a weight of 0.4. So content-based filtering has been prioritized slightly higher. The reason is simple. We want to prioritize the relevance of movies, which the content-based filtering provides, over the quality and the alignment to the user's preferences, which collaborative filtering provides. And therefore, the list generated is not random or irrelevant like the list generated for collaborative filtering was, and also it is diverse and more personalized for the user, unlike the content-based and cascade hybrid system. So we are getting best of both the worlds, as we promised in our model. So as you can see in this graph, the diversity calculated for 30 random users and their recommendation list was different in each case, which means that the list generated was different in each case, which means that the personalization is not 0 like content-based or cascaded system. And it is actually 0.38, which means that 38% of the movies are not repeating in the list of generated for two different users. So we're getting a good average diversity of around 0.9 and a good personalization score of 0.38, which is a perfect balance, considering that if we put the weight of collaborative filtering to 0.5 or 0.6, what happens is that movies which are outliers, like Shawshank Redemption and in this case The Godfather, they enter the list because they have a very high predator rating, since all the users who have watched those movies have rated those movies very high, and therefore it basically makes the list again more random and irrelevant. And therefore we kept the weight of CBF slightly higher. Now, as you can see in these graphs, what we've done is we've plotted weights against the personalization score. Now, when we keep the weight of the collaborative filtering 0.1 and the content-based filtering 0.9, what happens is exactly the same that was happening in the content-based filtering system. The percentage score is almost 0. And if we do the opposite, then what collaborative filtering results were showing are the same results that we can see here. The percentage score is around 0.7. And so basically what we can infer from this graph is that if we increase the weight on the collaborative system, the personalization increases because we are giving more priority to the user's preferences, the quality of the movie. And similarly, in this case of diversity, when we give the 0.1 of weight to the collaborative filtering and 0.9 weight to the content-based filtering, the diversity is around 0.85, just like it was in the content-based filtering. And if we do the opposite, then it is 0.98, just like it was in the collaborative filtering. So what we can infer from here is again the same, that if we increase the weight on the collaborative filtering, the list starts getting more diverse. And if the collaborative filtering weight is higher than the content-based, then the list starts getting more irrelevant and random. And therefore, we have to find a perfect balance, which in our case was 0.6 and 0.4. Because as I said earlier, if we keep the weights same, then outliers like Shawshank Redemption and other movies which are usually high rated enter the list and make the list more random. So in conclusion, our model alleviated the issues of both the individual recommender systems. Content-based has the issue of over-specialization and collaborative has the issue of cold-start problem. Our model alleviates both of these issues. It also outperforms the cascade hybrid recommender system in terms of handling the disadvantages of the individual recommender system. As I said earlier, cascade was not able to alleviate the issues of content-based filtering. We also provide a better user satisfaction in terms of the diversification and personalization score, which are much more balanced in our case compared to the rest of the three models.
That's it. Thank you for your time.
Sanket is there. Dr. Gayatri, if you want to ask any question to him.
No, I think it's okay. I don't have a question. Do you have
any delegates in the attendee? If you want to ask a question, then you can unmute your microphone and you can ask. I think.
Hello. Yes, we are here. Hello, I'm Nilay. Yeah, we are here.
Yes, you are audible. You can ask the question.
No, I don't have a question. I thought you had a question.
Okay, Nilay is there. Okay.
Yeah.
Okay, on the lighter tone, maybe I'll ask one question to Sanket. You did so much of analysis on movies. How many movies did you finally see with the recommended list? Lighter tone.
Yeah, sorry, his audio is not working actually, but I know him and he has actually seen many movies for this analysis we made.
No, those that were recommended, right?
Yeah. Actually, he might have seen all of them actually.
Okay, fine. Thank you. Yeah. Dr. Patel, do we want to have the second video or are we running out of time?
We are running out of time, and because of this time constraint, I think we could not play that pre-recorded video of the paper ID 208.
208.
Yes, so I think we can conclude this session.
Okay, fine. So thank you, Dr. Patel, for giving me the opportunity to chair this session. We have had 4 papers for this session, of which 2 papers were presented live and 1 paper was presented, the video was shown, and due to lack of time, we have not been able to show the final paper, the 4th paper, which was available in the video format. So,
thank you very much, Doctor, for sparing your valuable time for us, and we are grateful for your cooperation in this conference. Thank you very much, ma'am.
Thank you. My pleasure. Now we have the keynotes, right?
No, we have third session, technical session.
Okay, and then the keynotes.
Yes.
Yeah.
Just a minute.
That is at 1:30, correct? Yeah.
Yes.
Yeah. Okay, fine.
Dr. Kumar, Vikram Kumar, are you there? Yes, just a minute. Your sound Yeah.
Good afternoon, Dr. Patel.
Thank you. I'm just making you the presenter. Means.
Yeah.
Okay. Just a minute. So I think we can start this third technical session. Dr. Kumar, if you are ready, then we can start this thing.
Yeah, sure, sir. Definitely we can start.
Okay. So Dr. Kumar, I would like to welcome you to this third international conference of on a soft computing and its engineering applications, that is icSoftComp2021. And Dr. Kumar is working with Triple IT, Pune, and his research interests are mainly in artificial intelligence, machine learning, and this deep learning. So I welcome you, sir, Dr. Kumar. In this third session, technical session, we have 4 papers, and out of this paper, 2 papers are authors of the 2 papers are going to present their paper live. One is like we have a pre-recorded video, and one paper we don't know actually. He has not given any feedback or not filled that Google form. But
Okay.
we'll ask him if he is present over here, then we can make them present.
Okay.
So first paper is 212. Paper ID is 212, and the
Okay.
is Krishnan N and Gerard Deepak.
Hi.
Are you there?
Yes, I'm here, sir.
So Krishnan, are you there or?
Yes,
Deepak?
this is Krishnan.
Okay. So I think 1 minute.
Yes.
So your team ID is 008, Krishna? Or it's Vikram Kumar, it's Dr. Kumar, no?
No, my team name is Krishnan. Krishnan.
Okay, just a minute. Okay.
Yes, I got the presenter.
Now you are present.
Yes. Can I start with my presentation?
Yes, you can share your presentation or you can share your screen.
I hope my screen is visible.
Yes, it's visible.
Yes.
Krishnan, you have 15 minutes to complete your presentation. So just try to complete in 12 to 13 minutes and 2 more minutes for question answer session.
Sure, definitely.
Dr. Vikram Kumar, now it's in your control. You can share the session.
Yes, sir. Thank you.
Hello, everyone. I am N. Krishnan. I am from SRM Institute of Science and Technology. I am here along with my co-author, Mr. Gerard Deepak from National Institute of Technology. Today, we are here to present our paper, Knowledge-Centric Entity Population Scheme for Research Document Recommendation System. So, you may wonder, what is this topic and what is it all about? What is the problems which we face during creating it? What is the problem statements which we are trying to solve and how we are solving it? So to give a background about our paper, basically we started collecting data from the web, for creating research papers, and we see there are exponential amount of data present in the world wide web. That too, as we are going towards web 3.0, there is a lot of research coming upon, and there is a lot of scholarly articles, and as these scholarly articles are very closely related to each other. Let's say you're going and searching and recommendation algorithm, and you can see there are like 5 to 6 approaches to find the solution for the same problem. So it creates a confusion, what algorithm do you actually, or what paper do you actually recommend to your user, right? So this is a huge problem which is being faced. So we might have to go deeper into this algorithms, so that we find a proper way to channelize and give a proper recommendation to the user. So in this paper, we are proposing a knowledge-centric approach for the research paper recommendation system, where we are using semantic similarity and gated recurrent unit along with cuttlefish optimization algorithm, so to as to give the best related recommendation articles to the users. So we are taking multiple channels, wherein we take user query, user quicks, and we are also trying to figure out a way to give and take into consideration about the existing knowledge present about the paper's recommendations, so as to give the best accuracy F measure to the user. Here we have attained an accuracy of 96.63% and an F measure of 96.69% respectively. So as I already told, as there is a lot of technological advances present here, the data generated also is more, and there is a lot of research paper has been released and publishing online. That too, thanks to it's might be our technological advances, which made us, the conferences online, make the more research available to everyone. It comes with a disadvantage also, wherein as it creates a huge overload of data. So it's causing, as there are more researchers coming up, it consumes a lot of researchers time to search on, to find what exactly are they searching for, and what paper is actually verified and what paper is not actually verified and published according to the publications reputation, etc. So to find this, we are contributing, as I already mentioned about our contribution. So according to the related paper, Mr. Song Shun et al. Has described a method wherein we use ontology to create user profile, and once the user profile is generated, we are creating we are finding the resonating the user's interest, and then we are creating an activation model to create a network of recommendation systems to show provide recommendation to the user. But the thing is, it is not a knowledge centric model and does not provide a generalized solution, like a tailored solution for each users. The main purpose of recommendation is to give a user a tailored experiences, right? If this is, even though it reduces time for the user to, user or a researchers, even though it reduces time, but it doesn't actually solve the problem completely. So we went ahead with a model which is done by Morocco et al., wherein a citation graph and a random walker characteristics based approach is being used to recommend related scholarly articles. But the thing is, again, here it reduces the time. Okay, the system's preference score is linked with the document and the quotations present by it, the citations. But again, it doesn't consider a lot of user queries and user clicks here. So we have to consider that along with this to give the best recommendation system. And then we went ahead with Jusnik et al., where he proposed a system where a web crawler is used to retrieve the papers, and paper are compared to text similarity to get the collaborative filtering method. So here it actually has the main feature about this paper is that they are using a crawler system, which is a positive note. Along with, they are also using a semantic similarities, so that to come in as a combination of both of these, this gives a huge load on, it gives a huge positive boost to give the best recommendation system. But the thing is, this doesn't also use a knowledge centric approach, and there's no optimization algorithm used here, as as the data is very large. If you don't use an optimization algorithm, even if the system does the work for you, it's still going to take a lot of time, and the accuracy and F measure might drop down a little. So to move on with our system, I want to explain our proposed architecture, wherein first we are making the user log into the system, wherein we collect the current users, current user clicks, processing and obtaining term. Okay, and then we have also taking, you usually will be using a query term to search in our paper, right, for the research works, right? So we're going to take the query, that we are going to process the query, and then we are going to update the query words. And here we are also, as a part of pre-processing, there is a this is a three-step process where we are tokenizing it, we are lemmatizing it, and then we are doing stop word removals to get the perfect term of what exactly the user needs. So once we get that, we are formulating term tree based on semantic similarity computation. So here we are the formulating term tree will something look like, the user clicks based on user clicks and the user query search. And here we have added an added feature. Sometimes, as myself, I was previously working on, user, like UI UX design based searches. And once I shift to a new project, I was searching on artificial intelligence and machine learning optimization based papers. So even though I have searched on it previously, it isn't mandatory that I'm using the same data for the current research work also, right? So that's why you are using current user clicks. So for the current user clicks, we are using something called a session management, wherein we manage the session and we are actively tracking about the user projects. So here, as an additional step, we are using as a current user click. So that is an added feature. Once we formulate the term tree based on the semantic similarity computation, where we used a function which could, create a semantic similarity index between the obtained query words and the user's previous clicks. Okay, and we are again performing term entity aggregation. So as a term entity aggregation, we are using semantic to enhance this the query terms which we have right now. So let's say we have term like machine learning, or if we have a term like long term, short term memory. So we are using the semantic VBS, DB, and LSI to aggregate this term to create a more enriched term tree, so that you have a word, a synonym of the word, and more other synonym word, and there's other citations present to it. And we are again performing the we are again computing semantic similarity here. For we are having a separate research paper data set, wherein we take the previously formulated uh, term tree, and we are using a GRU classifier to extract what and all research paper which is somewhat relevant to the user, okay, before performing the entity term aggregation. Okay, and then we from the classified data set, like we will be having a searches, right? Like let's say we have a 1 billion research paper data set. From here now we are reducing it to around 40 lakh 30 lakh papers. Here, from the enriched term tree, from the GRU classifier, we are going to further reduce it by computing again a semantic similarity here, and then we are going to rank it according to its semantic similarity values, and then we are going to recommend it to user. That's how the user journey is for the proposed architecture. For implementation, we use Google Collaboratory, wherein we took the research recommendation data set, where queries were used during the implementation from the both manually and crawl through customized web crawlers, and we got an results out of it. So the matrices we used for our model were precision, recall, accuracy, and F measure. To explain more about our proposed system, the average precision was 95.36%, the average recall of 97.89%, and accuracy of 96.63%, and F measure of 96.69%. You can see our model is dominating other models which we saw during our previous measures, which we discussed previously on our related works. This is because we are using, we are computing semantic similarity twice. To increase the accuracy, we are using performing term entity aggregation, where we enrich the terms again and again to give out the best similarity index. And we are also using, as you can see, we are having an FDR measure and NDCG measure as very low for our model, because the false ratio is less. This is because we are using a GRU classifier along with an optimization model as a cuttlefish optimization algorithm model to optimize our results to give out the best possible values. And we need more number of recommendations, right? So you see go to many website and articles, you see first list of recommendation, then go to next, but you can see that as you go, as the number of recommendation keeps getting more and more, the actual accuracy of it keeps dropping, right? So we perform that analysis also, compared our models with our related works models, and we came that you can see very clearly that even when the number of recommendation is 10, we had a we had our highest recommendation accuracy. And then even when we keep increasing our recommendation to 15, 20, 25, and even it's at the most value of 50, we still got the our accuracy is still higher than the previous model. As I already explained, this is the end results which we achieved with our architecture. So to conclude, the research paper recommendation plays a very important role in our day-to-day life, and as a researchers, we all need relevant data to come as quickly to us to complete our research works, and it should be more accurate, and it should cover all the in-depth analysis of our research. Having using a GRE classifier and performing the term entity aggregation, it gives us using a knowledge entity centric approach, we are giving a best research doc and recommendation system with our limited amount of time. And we can see that very well, see that knowledge based approach is giving very well accuracy, very high accuracy. So even to improve these models, to make our model further more efficient, we can as we are using more knowledge based approach and more knowledge based ML models integrating with it, will give further more enhancement to our work. Thank you. These below are our references. Hello.
Hello.
Yeah.
Yeah. Thank you, Krishnan. Thanks for presenting such a nice work. And I have a few queries to improve my understanding about the work.
Yes.
So the first question related to the is related to this the database that data we used. So would you like to tell something more about that? Because I could see there was one number, something related to the around the 4,000. Whether that's the word size that you one has finally filtered out, or this is the number of the queries that has been generated. What was the
like we used 4,128 queries during this implementation, where we put that query and we searched for the recommendation. We used data set for testing and training.
Yes. Okay,
So
that was the queries. And what about the second inputs that you talked about? That the second input is the user clicks, right?
Yeah.
Yeah.
The user clicks, and for as it is a real-time data set, the real-time data set which we got from Google Collaboratory, Google Collaboratory models, where we got pre-trained data sets for to find out that to get the theoretical output for our models. We used the data sets from there, and Google Scholarly data set is also used to to get some open source data set and tried with it. We were all of our testing were happened basically on the Google Google Scholarly data set. So as I already mentioned, to further improve our model, we can try with more real-time data sets, as try with multiple data sets and check its accuracy.
Yes, and in my another understanding, if we are only using these two parameters, okay, correct me if I'm wrong. If you are only using these two parameters, then in the real life, it's going to take time to build up a particular user's query database, right?
Yes.
Right, and the system, the proposed system is expected to improve with the passage of time. Is that correct?
Yes.
So is there any, during the initial phase, is there any other parameter that you would like to combine so that results in the initial phases are also up to this expectations?
Yeah, like we are using initially, it will be obviously based on collaboratory filtering model to eliminate the cold start problem. So as you already know, in recommendation systems, cold start problem is very prominent. To
Yeah.
just avoid that, we are using a collaboratory filtering
Okay,
model.
initially there's a collab.
Yeah, so initially it will be using collaboratory filtering model. So that's why I wanted to introduce a session based system. Especially I face that problem many times. Keep as we keep switching the domains as we are going and searching. Next time when I switch to another research project, I'm still getting recommendations from my previous models.
Previous
So
one.
yeah, so the previous queries. So we need to, as and when the project is over, we need to give an option to the user to to create a new session or a new collaborative filtering like it's basically resetting
Yeah.
into a collaborative filtering model to give out a more accurate recommendation system.
Okay, that's nice. That cleared my doubt.
Yeah.
Anybody else who have any other questions?
I have a small question. Krishnan, Mr. Krishnan, did you, you know, after completing the implementation, have you tried, getting research article for this paper? Was it accurate as to what you have used in your paper as a related articles?
Yes, to be honest, yes, it was a really good experience, and yeah, hopefully we are trying to build this to a large scale model and make it available to either we can submit it to either Google Scholarly or make it an open source software so that all the other researchers can also benefit from our recommendation system to make their work more feasible and easily accessible for everyone.
Okay, this is a backend system, right?
Yeah.
All right, Krishna, nice work.
Thank you.
Thank you, Krishnan.
Thank you.
Dr. Kumar, shall we move to the second paper?
Yes, I think we can move to the second paper.
Okay. So, Dr. Gaba, are you there? Vishal Gaba?
Very good morning, sir. Very good afternoon, sir. Yes, I'm there. Sir, can you hear me?
Just
yeah, you are audible.
I'm making you the presenter. 1
Yes.
minute. Yes, Vishal. Now you can start your presentation.
Yes.
You can share your screen.
It's visible?
Yes.
Yes. So good afternoon, sir. My paper is on sentiment analysis of Twitter data, and that will be using machine learning approaches. So I'll just start. Sorry, actually, I'm having a little cough today. So sorry for that.
No worries, go ahead.
I just request you to complete your paper in 10 minutes.
Yes, sir.
Thank you.
So as we all know that NLP techniques and sentiment analysis is beneficial not only in advertising in marketeers but also for real-time strategies. It's a very hot topic, and it's although it's going on from some time, but still there is a certain amount of research that still can be done to improve its accuracy. That is the area because with the current techniques we have many techniques for sentiment analysis, but if we have an accurate but there is still no guarantee that with any algorithm that the sentiment predict could be 100% accurate. But if we reach a good amount of accuracy, then it would be very beneficial for real time tasks, for marketing and other purposes, uh, as we all know. So it is still a hot topic for research so as to improve the present accuracy. So our research makes use of ML algorithms to address that issue. Now we all know that social media is becoming utterly pervasive. So for our study, we are using Twitter data to perform this task. I'll move forward. Uh, for our research, I'll describe the problem description and challenges we faced. So we know that Twitter has the size. Twitter is a micro blogging platform with a size limit of 280. Has been increased to 280. So the problem is that it is not a blog. It does not have a huge amount of data per tweet, so it is difficult to get an accurate analysis. And also, most of the data is very noisy. So for improving our models, we need to take care of that very carefully before proceeding further, because that is the main point for as we are working on accuracy. So that is very important. So for that, our challenges are being uh, removing the retweets, likes and shares are not in many platforms, so that's are removed. And the main concern are hashtags, hashtags and emoticons basically. So we'll focus on that, as you will see as we go on in our presentation. Also abbreviations are also tackled. These are also some challenges so as to improve the accuracy. So methods, we focus on pre-processing. We focus on how we are downloading data, the hash the keywords we are using, about 180 keywords on 4 to 5 domains we have used. uh, and mainly the major methods used is using CNN and BiLSTM, and combining them to see what is the effect of combining them and making a hybrid model, as we have recently seen in the literature that CNN and BiLSTM are being used in a combined form to improve such analysis. So that's a hybrid approach, as you'll see forward. So one more thing is, like, we'll make use of uh, hashtags and emoji data to enrich our tweet text. Also, we realized that going through the literature, we realized that sentiment analysis, the effect of sentiment analysis, uh, the words is there on. I mean, and we have modified the TF-IDF formula using sentiment analysis for to improve further improve the accuracy. So for example, if you can see, we have used particularly it's our input to the paper, that what we have done is not using the TF-IDF directly for giving our input to the model. We do not need the text data, but we actually need it in a number and vector format, for which we use TF-IDF. Now, since we have realized from the literature that sentiment analysis has an effect on sentiments of the words have a particular effect on actually the sentiment of particular words has a good large effect on predicting whether the total sentiment expressed in a sentence is actually positive or negative. So we take into account that as well. So if we are getting so we take the opinion sentiment of each words as well, and if and we use that in a TF-IDF formula as it is mentioned over here. So we modify TF-IDF formula using the opinions of words as well, so as to improve the accuracy further. We tried and tested various methods, as you will see, and tried various algorithms as well. So, and here also it is also mentioned that we have used IMDb and tweet data from Kaggle as well. Also, I would like to mention we have downloaded tested majorly on our downloaded tweets as well, using uh, keywords that were collected based on a survey. Uh, Based on a survey, many keywords were selected regarding to 4 or 5 domains, and on that Twitter data was downloaded for further which sentiment analysis was performed. This is the main architecture of our system. We use the API and then pre-processing with some particular feature extraction. As I mentioned, hashtags, emoticons were taken care of. After which we did tokenization and included club vector embedding for weights, including weights in the model, and then finally predicted the polarity. So coming to the experiments and evaluation, we used, as I mentioned, we used classification models and classification models as well, because majorly initially as I started this and checking the code using Python and Google Colab. So initially it was going to be a survey of different techniques. So initially analysis was done on many models, classification models initially, after which we went further to neural network models. So as you can see here, here there is an comparison of how the accuracy is improving if we use hashtags, and then you include smiley as well in hashtag, and then we use generalized emoticon in one word. SM one word is smiley one word. So here we can see that the use of hashtag and smiley actually is improving the accuracy. To be precise, that means including hashtags and emoticons as text in data, that improves the accuracy. So not only these features, but a number of features and to reach even more, going further on our survey and analysis, and to develop our understanding more as to what is actually improving the accuracy and what is not, so that we could exclude those features and include what were really affecting. We did an analysis over a number of features, uh, going from small to big and increasing one by one. So we this is the general comparison of feature description is given on in the table as well, and an accuracy chart shows how adding different features actually affected the accuracy. Or in the next slide, I think we have F score as well. Yes, so accuracy, how it is affecting the accuracy accuracy of the performance of the model. So you can see in the last stage, J and K are actually, J includes the hashtag as text in the emoji, and K is after including the hashtag, that is J plus emoji also it includes. So accuracy really jumps up high. So we also see the effect of stemming and lemmatization as well. Moving forward, this is the same comparison done over F1 score. So as mentioned, we did classification models as well as neural network models. So here you can see what was expected, that CNN plus BiLSTM, that is a hybrid model, was expected to perform significantly as compared to other models. But what was actually observed, that for our data and generally our finding was that it performed really well and the findings were really stable. So as you can see, the accuracy, the different metrics are really stable in CNN plus BiLSTM, resulting in a uniform result for all metrics. Whereas in other models, either the accuracy or the recall and precision score are varying. But in CNN and BiLSTM, we see a uniform score. So that was really suggested as a preferred approach for going in such tasks. Also, we see higher accuracies when we are using SVM as well. This is the comparison based on the basis of various comparing various algorithms, various approaches over one particular data set. So we use this glove vector embedding to include this as weights in our model. So these act as pre-trained vectors that we used in our models as weights. So we conclude by saying that main components of our study was using this CNN biased studying and analyzing the CNN biased team approach, as well as including modified TF-IDF values. Also, we saw the various classification models in which SVM, naive-based particularly performs better for new data set and large data set, as it performs, as according to the literature, it performs really fast, but higher accuracies were seen for SVM as well as CNN BiLSTM approaches. So in future plan, for currently we have used only tweets pertaining to English language. So in future we'll try to include other multilingual tweets as well, so as to include a larger data sets on one particular topic. So this was it. Yes, sir.
Yeah, thanks, Vishal. So, anybody have any question to Vishal? Okay. If not, I'll have a quick question, Vishal. Vishal, what are you doing?
Sir, currently I have finished my MTech recently. In
Okay.
MTech, yes, sir.
Okay. Definitely nice work, and you should continue. I have a quick suggestion, in fact, to the previous presenter regarding the presentation. During this short presentation, we should try load the slides with the less contents, because otherwise it will not be possible. This is the general guidelines anyway. Most of both of your in the presentation, the text is too much. We should try to use the cryptic. Full sentences and paragraph are mostly not encouraged.
Yes,
right? So it will save your time as well, and it will give a very say clarity to the listeners. Okay.
Yes.
So can you quickly go to slide number 7? Yeah. Can you tell me quickly, just improve my understanding about this result that, okay, with the 2000 tweets as well as the 9000, we are hardly getting any improvement. Is what the interpretation?
Sir, actually, that is just an illustration of our work. Basically, not a comparison, but because initially analysis was done on 2000 tweets data set. All the analysis, all the algorithms were then again repeated for 9000 data set to see if there is any significant improvement when we are improving the increasing the number of tweets. But there was no as such very significant. But we can see that for had there was a improvement, but not that much. But yes, so
Okay.
that is not general comparison, but that was our approach. That first we did our full analysis on 2000 tweets, but later on to 9000, as well as for other data sets afterwards we carried the same thing again. Like
Okay, Vishal. Dr. Patel, any question? Otherwise, we can move to the next presenter.
So anybody has any kind of question? If you have, then you can ask. Okay. So Dr. Kumar, we should move to the next paper.
Yeah, sure.
So author of paper ID 059, are you there?
Yes, sir.
So your name is
Surya. Surya. Yes, sir. Like should I raise my hand so that you can
just
yeah. Okay.
Yes, you should raise your hand. Actually.
Okay, sir. Yes, sir.
Sir, is my screen still visible?
Yes, it's visible now.
Oh, okay. I'll just exit, sir. I am actually Vishal, so I'll just.
Yes, I made you attendee. If you want to attend, then you can attend.
Sure. Thank you so much, sir. Thank you, sir.
Yes, Surya. Now you are presenter, so you can share.
Yes, sir. Okay, sir. Yeah, so is the screen visible, sir?
Yes.
PPT?
Yeah.
Okay, sure. So yeah, uh, good afternoon, everyone. This is Surya Ram Shimnikar, and I'll take you through our journey of proposing this paper on database concentration method for efficient image retrieval using clustering and image stack comparison. Um, this is the paper's outline. So here we start off by the introduction. Here we have discussed various trends in image retrieval strategies. Next, in the literature review, we have divided this into 5 subsections where we have compared and surveyed various proposals in content-based image retrieval, clustering, object classification, tag generation, similarity coefficient, and feature extraction. Then, from surveying these papers, we have come up with our motivation to propose this paper. Then under results and discussion, we have covered information about the dataset used, the inputs and outputs, and things related to that. This is then followed by our results subsection where we have compared our approach to other approaches on the same cipher data set. And this is then followed by the limitations in our approach. So yeah. Coming to our abstract, the world moves towards a digital civilization. We generate more and more data along the way. With this increase in number of images on the internet and with social media companies, faster and scalable image retrieval algorithms are needed for efficiency. In this paper, we have proposed a tag-based image retrieval algorithm, which also uses clustering for better efficiency on larger data sets. For clustering images, we have used K-means algorithm, and uh, to generate new tags for unlabeled data, we have used IBM's visual recognition v3. Then to extract the image features, we have used the Resonate 50 architecture that is based on ImageNet weights. Yeah, yes, sir. Okay. Yeah. Yeah, coming to our insights from a literature review, we were able to categorize our findings in 5 basic categories. So under content-based image retrieval, we have found out that the most commonly used data set in the research field is the NUS wide. And while we are comparing the accuracies and MAP scores of the approaches on the cipher data set, we have found that the binary codes to retrieve images were the least efficient ones. And majority of these approaches have used some sort of convolution neural networks as their backbone for retrieving the images. And then coming to the clustering, we found out that most of the clustering algorithms that are efficient have used some sort of k-means algorithm or have modified it a little bit to increase its efficiency even more. And for image segmentation, we found out that fuzzy c-means is the most efficient algorithm. And for object classification and tag generation, we have found that for object detection, region-based detection techniques, they perform better compared to the unified object when computational power is like when we consider computational power as a criteria. And a combination of old approaches like CNNs are brought together with RNNs to provide better tag completion. Then for similarity coefficient, we found that the longest common subsequence method to match the strings is the most efficient one as proposed in the paper 19. And then finally coming to the feature extraction, the Inception ResNet V1 architecture performed almost as good as the Inception V3. And the ResNet architecture, when we compare a ResNet and an Inception, the Inception could provide a more intricate details about the image. So, yeah. Yeah. So coming to the motivation, from these insights, our motivation is to improve the tag generation speed of image retrieval algorithm and propose a method to generate tags for previously untagged data. We found the reason for slower image retrieval is due to extracting image features of the complete data set. We therefore have condensed the data set itself, significantly reducing the number of required extractions. This therefore reduces the time required to retrieve images from a data set. Our main motivation, our main innovation is that not many approaches have focused on the data set and have instead only focused on the image retrieval aspect. We found that retrieval time could be significantly reduced by processing the data. We therefore have pre-processed the data set by segregating and labeling the segregated folders. Along with that, existing label-based retrieval algorithms that are present require a pre-tagging done by a human, and we have therefore overcome this challenge, and we have completely automated this task of labeling the uh, clusters as well. And yeah, this is our algorithm overview. So we have basically divided this into two main categories. So the first one is database clustering. This is the pre-processing step. So this is done only once while when the data set is given. And the next one is the query image retrieval that will use this processed data to find the final images. So what we basically do is we have used ImageNet as a pre-trained model, pre-trained weights on a ResNet 50 model. We extract the features of all the images from the data set, and based on those features we apply a k-means algorithm to cluster them together based on the similarity. And each of these cluster is stored as a folder with some random name, some counter name. And then inside each folder, for each image inside the folder, we extract the tags using an object detection model of IBM visual recognition v3. We find the objects or anything, any features that are present in the image. So this could be the things that are present. It could be human, car, bus, or it could also be colors such as red, blue, and all that. And then we then pre-process this string, all those tags. We then pre-process them by using stemming and stop word removal, and we pre-process it basically and use that process string as the name of that folder. This completes the pre-processing part. Now when we are actually going to start the retrieval thing, same process applied. We first use the IBM's visual recognition v3 to find the tags that are associated with the query image. We perform the same steps of pre-processing the text by stemming and removing stop words and all. And then finally we apply count vectorization on every folder name and query string name. So using the count vectorization, we then apply a cosine similarity measure to find top three most uh, similar folders based on only the tags, only the names of it, I mean. And then once we find top three such folders, we can then apply any normal image retrieval algorithm to find how many ever relevant images we want. So for our thing, because we are focused more on this pre-processing step, we have currently used a very basic sort of cosine similarity based measure to find and extract similar images. And this is our architecture. It's the same thing as we have explained in the algorithm. So we can divide the whole process into 4 steps: clustering the images, naming those clusters, finding which cluster or folder is most similar to a given query, and then finally from those clusters we find out most similar or relevant images. So we've written steps for each of it. So for image clustering, it would be first extracting image features followed by k-means clustering. For naming the clusters, we used tag generation using the IBM visual recognition v3. We then perform stemming on it, and then perform uh, pre-processing on the string to remove stop words, and then finally concatenate together to form the folder name. For the folder similarity, we have again used the visual recognition v3 on the query image to find the tag. We perform the same step of stemming and pre-processing, and then using the cosine similarity, we find top three most similar folders. Once we have the folders for the image retrieval, we extract the image features again using the ResNet 50, and then for finding which is the most relevant image, we have simply used a cosine similarity to find it, and we store it in the output folder. So this is our specification of hardware and software. So uh, test we have tested the algorithm on an i7 9th gen CPU with NVIDIA 1650 graphic card.
Intervene you. Just
Yes, sir.
your paper in 2 minutes.
Okay, yes, sir, sure. 2 minutes, you're done. And yeah, so software recommend TensorFlow, NumPy, OpenCV, IBM, and NLTK. And these are results. So we have found our MAP score on the CIFAR-10 dataset was 43.5, I mean 0.435, and we were able to successfully concentrate the dataset from 50,000 images to only 15,000 images. So it has to only find features from these 15,000 images, and this is uh, a comparison between our proposed thing and other approaches that have focused on using CIFAR-10 dataset. So we can see that ours is greater than the other 5 compared. And in future, because we have not focused much on the actual image retrieval aspect, but instead we have focused on the dataset pre-processing, we have not used a proper in like state of the art image retrieval algorithm like SIFT and SURF. We have instead used a cosine similarity approach. We want to get this better using some state of the art approach so that the algorithm performs even better. And using better hardware, we can even train the model for larger amount of epochs so that we'll achieve better results. So yes, sir, that's it. References. Thank you, sir. Done, sir.
Okay. Yeah.
Thank you.
Thanks, Surya. So,
Thank you,
anybody has any question for Surya? Okay. There is no question, Surya. And I have a quick question actually.
Sure,
again,
sir.
to my understanding.
Yes.
So basically, the whole of the algorithm is actually doing a trade-off, isn't it?
Yes. Yes,
It's
sir.
basically shifting the computation from the real from the pre-processing stage. Am I correct?
Yes, sir. So instead of focusing
Yeah,
totally,
instead of doing that task in the
yeah,
real time, I'm doing that classification in the
yes,
pre-processing and then
yes,
getting the advantage of that, right?
correct, correct, yes, sir.
Okay. If that is the general idea, then don't you think that pre-classification, right? That becomes a static. If I have to use the same database for any other classification, then again I have to do all those pre-processing. Then that generalized feature, right, that is lost because now I have classified the data set.
Yes, sir.
Right. So
Yeah.
I made my data set for a single purpose only. If anyhow my application need any second data set, I have to basically redo all the computation. Is that correct?
Yes, sir. We need to redo the pre-processing. Yes.
Redo, and if any functionality allow wants both of the features, then I might have to host two different data sets, right? Two different classifications of
Correct.
same data sets.
Correct, sir.
Okay. Yeah. So anyhow, think of this.
Sure,
Okay.
we'll think about it. Yes, it was a very valuable suggestion. Yeah.
Yes. And again, same suggestion. Try to reduce the this content on the slides. The lesser
Yeah.
text is always preferable.
Yes, sir. Yes, sir.
Okay.
Just
Thank you.
the printed text instead of paragraphs.
Yes, sir. Okay. Understood.
Dr. Patel, definitely we can have that.
Yes, sir. Thank you, sir.
Just a minute. Sorry. Yes, Dr. Kumar, thank you very much for sparing your valuable time for us in this icSoftCom. We are just meeting first time in this.
Yes, definitely we are ready first time.
I'm sorry that whether you will come here or not. Although yesterday you give the confirmation.
Yes. Definitely, it was my pleasure to be the part of this, to listen to this presenter, so and to meet you definitely.
Yes, sir.
Yeah.
Thank you very much, sir. Again, we are very grateful that you are here in icSoftCom. So last paper is like a pre-recorded video, but because of the time constraint, we are not including in this session. But we may, if time permits, then we may include that in a next session. Thank you very much. Thank you very much, all of you. And right now we have a break from 1 to 1:30. At 1:30 we have a keynote speech So we'll meet again at 1:30. Thank you very much. Thank you, Dr. Kumar.
Okay, thank you, Dr. Patel. And same thing, I'll try to be there in the evening as well. Yeah, it was a nice thing. Okay, thank you.
Thank you.